Hello and welcome to my video lesson 1.2a. We're looking at graphs and equations of polynomials. So basically we're going to start off with a bunch of characteristics of polynomial functions, polynomial graphs, and based off of those characteristics you can determine that a graph is matched to a certain function, or you can go from the graph and find the function, or you can have the function and draw the graph. Basically back and forth. So there's a few things we have to talk about first, and then I'll just draw out some situations here below. I do have a Math 30-2 video, very similar to this, where we talk about most of the same concepts, but not multiplicity. But all the rest of these topics here are also in 30-2. So if you want to look at that video, it'll be linked top right corner for you guys in the card. Okay, so the end behavior is all based off of the leading coefficient. So what is the leading coefficient? If we have some sort of polynomial, f of x equals, and we write like 3x cubed plus 4x squared minus 7x plus 2, whatever the value is, the leading coefficient is the coefficient that is in front or leading the polynomial. So it's the number that's in front. And what does it mean in front? We could just rearrange these however we want, right? Well, sort of. We can, but when we say in front, we mean the one that has the highest degree. So you can see here that this one has degree 3, 2, 1, and 0. So we are choosing the one with the highest degree. Okay, which really leads us directly into our next topic, or next characteristic, which is degree. So degree is taking the highest degree variable and putting that highest degree variable as the degree of the entire polynomial. So in this example here, we would say the leading coefficient is 3, and ideally we should have two different numbers. I'm going to do that right now. I'm going to make that different number. So maybe let's make this 5. So leading coefficient is 5, and the degree is 3. Okay. Now the next concept here is the zeros, which basically we have to know that there's different names for them. There are zeros, obviously, x-intercepts, and roots. All of those are perfectly valid answers, and we can also write it this way. So where y is 0, or where f of x equals 0. Okay? So basically every time it hits through the axes here, that would be a new root. So you have to just look at what those roots are. All right, looking at the next part, we have y-intercepts. Well, y-intercepts, it's wherever it hits the y-axis. So where f of 0 is something. Okay, so whatever that the x is, if x is 0, so this is if x equals 0, whereas for the x-intercepts, it's if y equals 0. All right, continuing on, maximum and minimum points. So I'm just going to quickly draw another graph here. This would be a quadratic, okay, where we've shifted the graph down by like whatever that is, 1, 2, 3, 4, 5, 6, 7. So this point here, the 0, -7 point, tells us that the y value, the minimum y value is -7, and y has to be greater than or equal to -7. Right? Which leads us also into range. So that would be our range. The domain in this question, in all of the questions really, is x is in the real numbers. But you might notice that the range in this question, because it's quadratic, shows up like this. But in this question, which is a cubic, we actually have a range that is also just y in the real numbers, and a domain that is x in the real numbers. So because this continues on going this way forever, and this is continuing on going this way forever, that is how we decide our domain and range. Which, going back now to the very beginning where we said n behavior is related to the leading coefficient, what you do is you look at the leading coefficient and you see if it's positive or negative. Okay? If leading is positive, okay? If the leading coefficient is positive, then it will go up to quadrant 1. If it is negative, then it will go down to quadrant 4. All right? This is our n behavior on the right side of our graph. What about the left side of our graph? Well, if the degree, and we'll go through some examples here, if the degree is odd, okay, if it's odd, then they have to go in opposite directions. Okay, if it is even, then same direction. Okay, so what do I mean by that? Well, if you look at my degree 3 thing that was happening here, you can see how they're going in opposite directions. Whereas in my degree 2 thing over here, they're going in the same direction, both up or both, and let's just do this, or both down. This would also be an even degree. This would also be an even degree. Oh, that's not very good drawing though. This would also be an even degree because they're going the same direction at the end. Okay? Whereas, instead, this would be an odd degree because, again, they're going in different directions. So, depending on the direction, we know the degree is odd or even. This is huge. Okay? And depending on the direction at the end, we know if the leading coefficient is positive or negative. Okay, so let's go ahead and just draw a couple things here and get so basically test this stuff out a little bit. Okay, let's test this stuff out. So first stuff we're going to look at is the n behavior. Okay, without going into too much detail, okay, this question up above is going to be n behavior which direction? Well, because it is positive, it's going to be up in this direction. Okay? What about on the beginning part, or beginning behavior, but end in the negative direction? Well, because it is an odd exponent, it's going to go off in the opposite direction. We don't know what stuff is going to happen here. Maybe something like that, maybe not. But it is going to be in opposite directions. Okay, what about the degree of a certain graph? Well, let's try to draw one. Okay, what is the degree of this graph? Well, actually we haven't even mentioned this yet, but turning points are a major component of this. So turning points are basically, you count up every point where it is actually changing direction, the slope changes direction. So this has 4 of them, and then you add 1. So count turning points, and add 1. Okay, so for your degree, this one has a minimum degree of 5. And we would say this has an end behavior of quadrant 3 to quadrant 1. Okay, local versus absolute maximum. Let's go ahead and draw something. This guy here. Oh no, that's not a good drawing. This guy here. Could even make it a little bit better. That's a little bit better. Yep. So a local versus an absolute max or minimum point. Well, here we have a local max, right? So that means it's bigger than the stuff to the left of it and bigger than the stuff to the right. Here we have a local minimum. That means it's smaller than the stuff to the left of it and smaller than the stuff to the right. And here we actually have the absolute max. And that's because it is bigger than every other point on the graph. Okay, so all of this stuff is covered in 30-2, and it's pretty straightforward. Now we're going to get through the part that I think most people have more difficulty with, and that is multiplicity. Oh, what have we? We haven't mentioned zeros yet. Yeah. Okay, let's just talk about zeros quickly. So if you find all of these points, I'm just going to make sure that they're on exact values. So all of these points, I'm going to actually write them down. This is 4, this is -1/2, this is -4, this is -8. If we put all of those together, we can actually make ourselves a little bit of a polynomial already. And assuming that nothing else is going on, this will be enough. So plus 8. So we're just taking all of our zeros, so plus 4, and then this one would be 2x plus 1. That gives us our -1/2 thing. And then this would be x minus 4. So that just lines up with all of those zeros. So if we plug something into a calculator, we could go ahead and find those, and I'll show you how to do that in a moment. Okay, but, well, maybe I can do that right now. Why not? Let's do it. Okay, let's try this out. So let's go with x plus 4, x plus 8, x, no, let's go 2x minus 1. I'm going to make it slightly different, but close to what we had, x minus 4. Okay, so, oh, and it's too big. Okay, well, at least you can kind of see the graph right now. Oh, and we should have a negative exponent, right? So we need to actually flip it around to make it quite right. There you go. Now it's closer to what I drew. Okay, so what we want to do to find the 0 points is we click second function, trace or calc, go down to 0, and we go like this, and we, whatever the point is, we go left bound, enter, we go right bound, we have to go to the right of the point, then we have to go and guess the point, and so it'll find our 0 point. So wherever y is 0, it gives our x value. So we have to surround our point and try that. The other thing we have to do, and I'm kind of looking like this is a little bit small still. Okay, whatever, it's close enough. So the other thing we can do is we can go second function calc and find the minimum point. So let's go find the minimum point down here, and we can also find the maximum point. So this is left boundary, right boundary, enter, and so now we have a minimum point here. So you can also find minimum, maximum, all using that functionality. So that's second function calc, and that's where most of this stuff is. Okay, most of the stuff that you're doing will be in that sort of category. Okay, multiplicity is where we have a point. So let's say we start up here and we go down, we reach a point, and then we go back up. Okay, and so it hits the x-axis at that point, whatever point that might be. Okay, that point there, if it hits the x-axis, that is a multiplicity point because it's just hit it and it hasn't gone past. The other thing to recognize is that we can have a multiplicity of 2 or of 1. So right here we have another multiplicity point. So maybe I'll do this in purple. Okay, so if this is the graph that's happening, okay, this is a multiplicity of 2. Okay, this one, it curves twice. You can kind of see, again, turning points. If you count up your turning points like this, right? This one curves twice, so we call this a multiplicity of 3. What does that mean in terms of actually getting our function, though? Well, it means that whatever that point is, so this is negative 1, 2, 3, 4, 5, right? Negative 5, comma 0. And this one is positive 5, 6, 7, 8. 8, comma 0. Okay, whatever those values are, oh, I guess it has to be negative again because it's going down, right? So we know there's going to be a negative because it's going into quadrant 4. But anyways, whatever those values are, x plus 5 would be our first one. And if it has a multiplicity of 2, that means we have to put an exponent to. And this one would be x minus 8. If it has a multiplicity of 3, we have to put the 3 up top there. So by finding multiplicity points, you can actually find some of these other values as well. So multiplicity points and zeros are the two ways that you can go from a graph into an actual equation. So let's see if I can just try that out in a calculator here and get it actually looking right. I don't know if this will work right away, but let's try it. So this is going squared, and this is x minus 8 to the 3. Okay, it's obviously way too big. Yeah, you can't really see it very well, but at least you can kind of see there's this multiplicity point in red here, and this one here, which is multiplicity of 3. And so those two together, hopefully it's kind of clear that, that those multiplicities exist because of what we've done with our equation. So most of this graphing stuff is really about knowing some of these main key characteristics and just doing your best. So you need to have like certain points correct, like your zeros have to be correct, and your end behavior has to be correct, and your multiplicity has to be correct. But after that, it's just going and drawing kind of the rest of it however you want, sort of thing. So just getting used to the idea of characteristics. of polynomials. So I hope this video helped you guys get a broad overview, and good luck everyone.